A resistance of galvanometer by Kelvin method. This experiment is used to determine the resistance of galvanometer. The formula for the same, G equal to R Lg upon Lr, where the symbols have their usual meanings. Circuit diagram for the same. If you see this as terminal A, this is terminal C, this is one L-shaped metallic strip, this is another metallic strip, and this is again L-shaped metallic strip, and here we can say B. This we called as a meter bridge. If you see the apparatus here, this as a meter bridge, you can see, which consists of one L-shaped metallic strip, middle metallic strip, and this as another L-shaped metallic strip. The wire from terminal A to terminal C has a length of 100 centimeter. Can say A, B and C. If you see here this terminal I can take A, this I can take as a B, and this as my terminal C. This as a left gap of meter bridge, this as a right gap of meter bridge. In left gap we are connected galvanometer, which resistance of which we are supposed to find. This as a resistance box, that is variable resistance. Here we have left gap of a meter bridge, this as a right gap of meter bridge. In left gap will connect this galvanometer, of which we are supposed to find the resistance, and in right gap will connect a resistance box. We connected galvanometer in left gap and resistance box in right gap. The remaining part in this case, battery, plug key, rheostat. So if you see here it is, this is my battery, then plug key, and then we have a rheostat. Now let's see how to connect. A positive battery is connected to terminal A, negative is connected to plug key, second end of plug key is connected to fixed terminal of rheostat, and variable of terminal rheostat is connected to terminal C. So if you see, this is battery, so positive terminal of battery will connect to terminal A, negative of battery will connect to plug key, and from plug key to fixed terminal of rheostat, and variable terminal will connect to terminal C. This is how we connected battery to terminal A, then negative battery to plug key to fixed terminal of rheostat, variable terminal will connected to terminal C. Now remaining part is from terminal B we are connected jockey. From terminal B we connected what we called as jockey, which will slide over a wire. Now put the plug key. So this completes my circuit connection. If you see the circuit connection from above, left gap galvanometer, right gap resistance box, from here jockey, then battery, plug key and rheostat. Place the plug key. If you see in galvanometer, pointer is at 0, 0. Move the rheostat from one position to another position, and then see the position of galvanometer. If I move from one end of this rheostat from here to here, we'll see in galvanometer we are getting deflection only on one side. In galvanometer we'll get deflection only on one side, and if you see the scale is 0, 20, 0, 10, 20 and 30. On this side also 0, 10, 20, 30. that means maximum deflection you can take as a 30. Now as in Kelvin, we are getting deflection on only one side. So to find the balancing point, we have to keep pointer half of the full scale. That means full scale, if it is 30, half is considered as a 15, 1/5. So we'll keep this pointer on 1/5 to find the balancing length, and we'll adjust pointer on 1/5 with the help of what we called as a rheostat. It means a full scale deflection, if you see 30, pointer will keep on 1/5. That means pointer will deflect towards the left side of 1/5 and towards the right side of 1/5. And balancing point, that means pointer must be on 15. So 15 is considered as the 0 for balancing point. I repeat, since in Kelvin we are getting deflection only on one side, that is 30. So we'll keep pointer on half of that, that is 15, with the help of rheostat. So we'll see deflection on left side of 15 and deflection towards the right side of 15, and balancing point, it means my pointer must be on 1/5, that is 15. Now let's see how to take a readings. Here we have to go for trial and error. Take some value from resistance box. Let us say I am taking 20 ohm from resistance box. Then with the help of what we called as rheostat, adjust pointer on 1/5. So with the help of rheostat, I am adjusting pointer on 1/5. You see, this is how to adjust rheostat, right? And adjust pointer on 1/5, that is half of the full scale. Okay, pointer is adjusted on 1/5, half of the full scale, with the help of my rheostat. Now keep jockey on one side of the wire. We'll get deflection on one side of 15. One side of 15 I am getting deflection. Once I keep jockey on this wire, right? If I keep other side of the wire, say here, we will get deflection on opposite side of 15, but the deflection is very small. Let the get deflection properly. If I find the balancing length for this point, then I will get balancing point approximately around 74 or 75. But my condition says for better accuracy, balancing length must be 33 and 66. For this purpose, we'll adjust the value of resistance from resistance box. So 20, let's go for 70. Okay, now the moment we remove 70 from resistance box, let's see our pointer got deflected. So first of all, whenever I am removing any value from resistance box, I have to adjust my pointer on 15 with the help of a rheostat. So we'll adjust the rheostat so that my pointer must be on 15. So I am adjusting the rheostat and bringing my pointer on 15. So I got on 15. Okay, I adjusted rheostat. Now let's see deflection on both the side of 15 by placing jockey on one side of the wire. I am getting deflection on one side of the wire of 15. I am placing jockey on wire other side. Again I am getting deflection on other side of 15. I am getting enough deflection on both the side of 15. Now let's see how much balancing point I am getting. For this, move the jockey on wire. We'll keep jockey at this point. See whether my pointer is on 50. No. I'll move this. Okay. Still it is on 50. No. So I'm moving this. Right. No, it's not on 15. So we'll slide now, since it reaches near to 15. So now if I see carefully, my pointer is on 15. My pointer is on 15. Okay. So now let's see what is my reading. My reading, here it is. If you see, it's 57. It is 57. We have to see the upper scale. Why to see the upper scale? Because a positive is connected to here. That means current is flowing from here. So we have to see the upper scale. 0, 1 starts from here. So my reading is 57. So this reading is for this side. That means where I am connecting galvanometer. So this side length is my LG and total length is my 100. So 57 में से 100 में से 57 हम माइनस कर लेंगे. So I can say, so LG is 57 or 100 minus that you will get LR, that is 43. Now you can go for another way. Let us say 100 then 150. Not necessary to take this value, you can take any value, but my balancing length must be between 33 and 66. Now we are going for 100. So from resistance box I remove 100. Now we will see deflection on both this. First of all, remember students, whenever you remove any value from resistance box, your pointer will deflect from 15. So my first step, with the help of rheostat, bring pointer on 1,5. So I'll bring pointer on 1,5. So it is on 1,5. Once it reaches to on 1,5, then you proceed for reading. Let's see how much is balancing length. So balancing length, pointer must be on 15. So it is not on 15. So I'll slide jockey over a wire. Let's see where I am getting this reading. Now it is 15. Let's see where is my reading. If you see the reading carefully, just 1 minute. My reading is this 47.5. So LG is 47.5 and LR is 52.5. Then I'll go for 150. Took value 150 from resistance box. Remember students, first step, the moment if you remove some value from resistance box, pointer will move from 15. Adjust the rheostat, bring pointer first on 15, then you will go for reading. So I am adjusting pointer so that it must be on 15. It is on 1,5. Then find the balancing length. In the same way as we did number of times, my balancing length. Now let's see. Pointer must be on 15 only. It is not on 15. It is now on 15. What is the value? Value, if you see, it is somewhere here. 37 point, you can say 7. 37.7 is my LG. So I can say my LG is 37.7. So LG 37.7. This will be 62.3. Okay, we took only 3 values, right? This is for galvanometer in left gap. When we connected galvanometer in left gap. Now we are going for galvanometer in right gap. That means this galvanometer will connect here and resistance box will connect here, and will proceed in same manner. Now here a resistance box in the left gap and galvanometer now in a right gap. Procedure remains the same. You can select any value from resistance box, but your balancing length must be between 33 and 66. Now we'll keep galvanometer right gap for same value 70, 100 and 150. Let's see for 70 first. We took 70 from resistance box. Fine. Whenever you are removing any value from resistance box, remember a pointer gets deflected from 15. So first of all, with the help of rheostat, adjust pointer on 1 5. So we'll adjust with the help of rheostat on pointer 1 5. Let's do the adjustment. We'll bring pointer on 1 5. The pointer is on 1 5, 15, half of the full scale. We did the adjustment for rheostat. Now let's see the balancing length. We'll keep jockey on a wire, and if I see pointer is not on 15, so I'll move jockey at other place. Let's see, still it is not on 15, that means still we have not got balancing point. Now I'll slide over this jockey over a wire. Okay, let's see how much I am getting a length. Here I got deflection, null deflection, that means pointer is on 15. What is the reading on scale? If you see the reading on a scale is somewhere here, we have to see upper scale, that is 42.8, but you see now students, in this case we are connecting resistance towards left side. So this length, that is 42.8, that is LR. This length is our LR. So I can say, so our LR is 42.8 and 100 में से minus के will get LG. So LG must be 57.2. So this is 57.2. Then 100 and 150 in the same manner. We took 100 from resistance box. Remember, I repeat, whenever you are removing any value from resistance box, pointer will move from 15, adjust the rheostat, bring pointer first on 15. So we'll adjust rheostat and we'll bring pointer on 15, that is half of the full scale. So we are adjusting the rheostat, we are bringing pointer on 1 5. Then we'll see the null point, that means we'll keep jockey on one side. We'll see deflection is, pointer is not on 15. Then another point, still it is not on 15. So I'm finding the balancing point. In this case, I got null point is here. What is the value for this? We have value, if I see on pointer on a scale, it is 52.5. This 52.5 is our LR. This length is LR now. LR is 52.5. So my LG is 47.5. If you see students carefully, in this case we got the same reading. Reading may remain same. Then we'll go for 150. So I took 150 from here. Now how much I got balancing length? Now remember, as I said, whenever you remove any value from resistance box, pointer will get deflect from 15. Adjust the rheostat, bring pointer on 1 5. So I'll bring on 1 5. Now get the balancing point. I am getting balancing point at where I am getting balance. Let's see, here my reading on a scale is, it is 62. So my LR is 62. So LR is 62. So my LG is 100 minus करेंगे. So we'll get 38. We are taking only 3 readings. So this completes my reading for left gap and right gap. Now we are going for calculation. For calculation, formula is G equal to R LG upon LR. R, this value, this is LG, this is LR. So there are 6 calculations for this 3 and this 3. So we are on calculation part. Our first calculation, students, G equal to R LG upon LR. R is my 70, LG is my 57, LR is my 43. I kept 70 as it is. Here we'll use the log. If calculation simple, you can do it directly, otherwise you have to go by log. Anti-log, log of 57 minus log of 43. This is we did with the help of log. Then we got log calculation, uska anti-log nikala, then multiply by 70, I got 92.75. How to see the log, how to do the log calculation, this video already is uploaded on YouTube, you can refer from there. Then second calculation, G is equals to R, Lg upon Lr. So R is second time, if you see second time R is my 100, Lg is 47.5 and Lr is 52.5. So in second calculation, 100, 47.5, 52.5, 100 I kept as it is. Anti-log of 47.5 minus log of 52.5. See the log of this, then subtraction, I got this, iska anti-log dekha, I got this. 100 multiplied by this, I got 90.46. Then my third calculation, I have R is 150, Lg is 37.7, Lr is 62.3. In the same manner, log of 37.7, log of 62.3. Do this log calculation, we'll get answer this. 150, see if I multiply, I got 90.75. Then for right gap, we took as a number 4. In right gap, also if you see 70, 57.2 and 42.8. More or less in the same manner, we completed third calculation, then fifth and finally sixth one by same way. Then here we wrote value of G in this table for left gap and value of G in right gap. Mean of these two we'll find by adding this 3 dividing by 3, adding this 3 dividing by 3. This calculation we did here. Fine. First, second 3 dividing by 3, we got 91.32. For right gap, we got mean 91.66. Sorry, 92. This is mean for left gap. This is mean for right gap. Then we'll find the mean of this two to get the actual value of G. So 91.32, 92, mean we got 91.66. So finally, the resistance of galvanometer we got 91.66. That will write in our result the resistance of galvanometer 91.66 ohm. This completes my Kelvin experiment.